So far we've learned that the derivative of the cosine of x is equal to negative sine of x, and the derivative of sine of x is equal to cosine x. And those rules came about because as we were looking at patterns of finding the derivative, those popped up as being rules. There are also other trig functions that have rules associated with them as well. At the end of this lesson, you'll be able to find the derivative of a trigonometric function. You'll also be able to find a higher order derivative. Right, derivatives of trigonometric functions, remember we already know the derivative of sine and we know the derivative of cosine. If I were to go through that same process and we drew the slopes of the tangent lines for the actual functions, if I'm taking the derivative of the tangent of x, that derivative will end up looking like secant squared x. If I take the derivative of secant x, that will end up looking like secant x times tangent x. The derivative of cotangent x is equal to negative cosecant squared x, and the derivative of cosecant x is equal to negative cosecant x cotangent x. These are formulas that you will want to memorize so that you're ready to use them. Mostly it's just plugging something into the formula, but if you don't know it, you're kind of out of luck. All right, let's go ahead. Higher order derivatives, first of all, before we do examples. If I ask you, the first derivative, remember, was just f prime. If I want you to take the second derivative, so I want you to take the derivative again after you've already taken the derivative, then we'll put f double prime. So I'll just put 2 marks, and that means take the derivative 2 times. You'll notice if I would like you to take the third derivative, if I want you to take the derivative 3 times, I will put f triple prime x. Any number over 3, that just gets to me too many prime symbols, so I will go ahead and just put 4 in parentheses, so that doesn't mean raised to the 4th power, it means to take the 4th derivative. So now let's do some examples. Right, this one says here, find y double prime if y equals secant x. So we would like to take the derivative 2 times. So the first time, we know that y equals secant x. My y prime, knowing the rules for secant x, the derivative of secant x is secant x tangent x. So notice if you know your rules, it's a very simple problem. Okay, to get the second derivative, I now notice that we have secant x times tangent x. There are actually 2 functions being multiplied together. So we're going to let this first function be f, and we'll let the second function be g, and we need to use the product rule. So just like what I always do when I start the product rule, I'm going to work it out here. The derivative of f, the derivative of secant, is secant x tangent x. And then g prime, the derivative of tangent x, is secant squared x. All right, now from here, we're ready to use the product rule. So the second derivative will be f prime times g. So secant x tangent x times g times tangent x plus f times g prime. Secant x times secant squared x. And then from here we can simplify a little bit. If I have tangent x times tangent x, that will be tangent squared x. Oops, secant x tangent squared x. Notice that the squared goes in between. It's not just the x being squared, it's the entire quantity. And then plus secant x times secant squared x will be secant cubed x. And then we're just about done, but we always want to make sure, is there anything that I can factor out? There definitely is. Since they both have a secant x, I can factor that out. So if I factor out a secant x, I will now have tangent squared x plus secant squared x left, and that will be my second derivative. Okay, example 8, it says to find the 4th derivative of 2x squared plus 3x. Oh, that's saying that this is the 4th derivative, and it's asking me to find the 6th derivative. So we didn't actually have to start way at the beginning. So if this is the 4th derivative, to get to the 6th derivative, I first of all need to find the 5th derivative, and the way that I'll do that is just finding the derivative. The derivative of 2x squared is 4x, the derivative of 3x is 3, and since I would like to find the 6th derivative, we'll just take the derivative one more time. So the derivative of 4x plus 3 will be 4. So that is my 6th derivative. So hopefully now you can find the derivative using trigonometric functions, and you can also find a higher order derivative.